Okay, this is a really useful table for you to just to help you remember all the different types of decay. So we have alpha, where we're emitting an alpha particle. Remember, that's a helium atom. We have beta minus. We have beta plus. We're emitting a beta plus particle or a positron. Um, we have electron capture, where the nucleus captures an electron and then a proton becomes a neutron. I'll write this stuff down. And then we have gamma decay, where we have a metastable state of a particular atom that emits a gamma ray. So in alpha decay, the nucleus releases a helium atom. And when that happens, the daughter weighs 4 less and has 2 fewer protons. So the daughter nucleus has an atomic mass and it loses 2 protons. So its atomic number decreases by 2 as well. So for example, and you'll need to be able to identify these. I'll give you nuclear equations, and you'll have to either identify one of the unknown quantities within that equation or identify the type of decay that is occurring. So here's a good example of alpha decay. Uranium-238 has an atomic number of 92, will become thorium, I think? Thorium-234. Don't quote me on that. Doesn't really matter. 234 and 90. Notice it lost 4 mass units and lost its atomic number decreased by 2, and that's because it emitted this helium atom. All right, beta minus decay, the nucleus releases an electron, I'm sorry, no, the nucleus releases a beta minus particle. And converts a neutron to a proton. So this is going to have the same mass, the daughter nucleus, but it'll have 1 more proton and 1 less neutron. Good example of this, for example, I have 231, 53 iodine, I think, gives me something with the same mass, xenon, 231, but I've gained a proton in the process of this, so I have this as 54 because I've emitted this beta minus particle, and plus 0, -1 e. So beta plus, nucleus releases a positron. And when the nucleus releases a positron, the proton becomes a neutron. These have, the daughter will have the same mass. And it will have 1 more neutral, 1 less positive. Or 1 more neutron. One less proton. This proton has become a neutron in this case by emitting this positron. So carbon 11 becomes boron 11, has an atomic number of 5 plus the positron. All right, now electron capture. The nucleus captures an electron. And when it captures an electron, a proton becomes a neutron. Okay, this has the same mass. It has one more neutron and one less proton. In fact, it's the same as what we saw with beta plus decay. It has the same mass. It has one more neutron and one less proton. Remember, the daughter of electron capture is the same as beta plus decay. So, for example, I have mercury 20180, or mercury 201, plus my electron capture, the electron that I capture from the inner part of the nucleus, inner part of the shells, give me 20179 gold. Okay, so that is electron capture. Remember, the daughter is the same as beta plus decay. And then finally, gamma, the nucleus goes from a high energy state to a low energy state. The nucleus is the same in the daughter. Releases a gamma ray. And for example, uranium-238, that's metastable, will become U-238 plus a gamma ray.